life. AI will probably most likely lead to the end of the world, but in the meantime, there will be great companies, and these are the words of Sam Altman. With these words, I, Dr. Soma Majumdar, along with my team members, Dr. Swatantra Sahu and Mrs. Mausam Sinha, wholeheartedly welcome our esteemed guests, speakers today, participants, the AI enthusiasts, and other stakeholders from the length and breadth of the globe to this international conference on emerging trends in artificial intelligence hosted by Scope Global Skills University, Bhopal. We are delighted to bring together brilliant minds from various corners of the globe to fully virtual yet dynamic platform to explore the frontiers of artificial intelligence. Over the next 2 days, we have seen that we are going to find out how the ethical AI, machine learning innovation, AI in business, AI in healthcare, and how the problems to solution through the AI can lead to the most cost-effectiveness, lead to a cost-effective society. Today, we are honored to have Mr. Atul Kumar Singh and Mr. Rahul Jaiswal, who are going to give their expert inputs into our today's session. Let me introduce Mr. Atul Kumar Singh. He is a lead software architect of infotainment and ADS, Harman Becker Automotive Systems, Germany. Mr. Atul Singh holds a BTech in Information Technology from Maulana Azad National Institute of Technology, Bhopal, and has built a distinguished career in software architecture for connected and intelligent vehicles. Currently based in Böblingen, Germany. He began his career as a tech lead for Android telephony at Samsung's Noida Mobile Center, where he developed deep expertise in Android frameworks and mobile platform engineering. He then moved to Harman International, Bangalore, as a principal engineer, designing next generation connected car software for one of the world's leading automotive technology companies. He currently serves as a software architect at Harman Becker Automotive Systems, Germany, where he works on Android framework, software architecture for software-defined vehicles, in-vehicle infotainment, and advanced driver assistance system, technologies that are reshaping the future of mobility. With over 15 years of experience spanning mobile computing and automotive software, and a career that has taken him from India to Germany, Mr. Singh brings a rare combination of deep technical expertise and real-world industry perspective on how AI, connectivity, and software are transforming the automotive world, making him a compelling voice on the intersection of technology and next-generation vehicles. We wholeheartedly welcome you, sir, for this innovative session of artificial intelligence. Now we are introducing our second expert guest as well, Mr. Rahul Jaiswal, who is the Director of Engineering, Waymo, and he is also the author of Beyond the Merge. Mr. Rahul Jaiswal holds a BTech in Information Technology from ABS Engineering College, a PGDAC and CDAC, a product management certification from Duke University, and has recently completed an advanced program in electric vehicle technology from IIT Delhi, reflecting a career built on continuous learning and cross-domain curiosity. He is currently Director of Engineering at Waymo, a leading AI-powered sales-enabled platform, where he leads a 50-plus member engineering organization across backend, mobile, DevOps, QA, and architecture. Under his leadership, Waymo has delivered platforms serving 10 million plus users with measurable improvements in uptime, deployment speed, security compliance, and cloud cost optimization. His professional journey spans over 15 years across some of the India's most recognized technology companies. He served as technical lead at Harman International's core R&D group Harman X, contributing to the IRA voice assistant platform adopted by Tata Nexon and building voice features for vehicle and lifestyle audio products. Prior to that, he worked at Samsung Electronics Noida on NFC-based secure payments and multi-SIM telephony innovation. He also co-founded Deneur and has hands-on experience across startups, product development, and enterprise engineering. His areas of expertise include engineering management, AI first product ecosystems, microservices architecture, DevOps, security and compliance, and Gen AI integration, making him a practitioner who bridges deep technical execution with strategic business leadership. He is also the author of Beyond the Merge, sharing his insights and experiences with the broader engineering community. The Scope Global Skills University wholeheartedly welcome you also. So today we are going to have a very intriguing session on artificial intelligence. I welcome Mr. Atul Kumar Singh and Mr. Rahul Jaiswal and request them to please give their presentations talk.
Hi, good afternoon everyone. Thanks for the introduction. I'm not sure how much of that is like. Okay, let me start with this thing. So I will start with accepting one of the mistakes we have done here. So in the last 3 years, 2 years, everybody is talking about like LLM, Gen AI. It has become the talk of the town. And the thing is, we also did like for like 6 months or so, we actually thought like model is solving all our problems, and that was not true. And it's something beyond that, right? So I'll quickly present my screen and I'll explain you what we were doing. And just give me 1 sec. Okay. How my screen is visible?
Yes, sir. Yes, sir, your screen is visible.
Yeah. So the problem is not the model. So model is basically works well. Okay. So the job of model is if you give some input and based on the training, model will give you some output, and that's what a model does. But beyond that, when you actually put it into the practice, put it into the enterprise product, that's where these models fail. And the reason are obvious. I'll talk about those in the upcoming slide. Okay. So we did this. I've done this talk with some other group of people, and I'm sure I'm not in person there. I would have done it with you. So I'll just put my insight from that session. So where I asked them like how many people, almost everybody has read something into LLM, but most of them they got actually stuck where they had to work on when reliability came into the picture, right? And when persistence across the session came into the picture, right? And that actually is something which we also felt, and we like that this is basically I'm working in the fintech industry, BFSI industry. Atul, on the other hand, he's working into the automotive industry. But when we discussed, we found the problem is same. It's not a different problem. It's a industry agnostic problem, right? So if I talk about the problems which about our specific industries, so in BFSI what we have it as of today, Wino has more than 500,000 agents who are using our application, right? In insurance and in BFSI, basically a lot of workflows are there which takes into place. And initially when we started, the AI was only working on like pieces of that. Okay, so it was not able to full-fledged cover the entire use cases. Right. Similarly, in automotive, Atul, if you want to cover.
Yeah. So in automotive also, it's the same problem statement, just disguised in a. By that I mean, we do have a lot of vehicles now on the road. The vision is to have all of them connected so that they can talk to each other, and to have AI assistants taking preemptive actions. Right now, AI is very nascent stage, just because of safety reasons. We don't want to have the users or the driver safety. But that's not where we want to stop. We want to go ahead with AI having preemptive actions. But it can only do it once we are able to solve the problem.
So if I, again, the same mistake which we were talking about, most of us started using LLM as a chatbot, right? Where we say something, so, and as well, believe me or not, most of the industry, ChatGPT, Gemini, that's the AI for them, but that's not true, okay? While what we are proposing is, and what we, and the industry is moving towards is using LLM stack, okay? Where there will be different layers, like persistence layer will be there, reasoning layer will be there, action layers will be there, and then states will be there, and then basically you can use LLM or these capabilities as you are using any microservice, so you can actually hook it up and actually get your things done, right? So now there are three problems which we have classified for today. Actually there are four. I'm not covered one. I'll tell you anyway. So first problem is the state problem. So the state problem. So basically, I mean, if you see the B2C application, there this problem might not be there, but it does not. It is a problem in enterprise applications, in B2B application. So basically, when you communicate with ChatGPT or Gemini, as of today, it persists the knowledge across the session, right? But that knowledge is just the information, it's very, very hard. It's just the textual information which you have, right? It does not have, but in B2B, it's more on the actions, more on the goals, and beyond that. So basically, in this particular example, if you see, agent says, I need a clear needs a follow-up, and the next session, if you do it from some other platform, it does not understand that. This is not exactly true in case of B2C, but in B2B, it is true. How I like it. The thing is, there may be several other facts related to this particular person. This person may not be part of the organization, or this person may not be available today, or something like that. So all those facts are something which are not part of the persistence right now, right? And that's what we are trying to solve. We are trying to build an explicit persistence layer where all these facts can be filled, right? And then it will cater the agents in order to act upon, right? It will improve the action. So that's why I'm saying in B2B it's completely different. Okay? It's not like B2B, and ChatGPT is not only AI. While in case of automotive, Atul, you know how it is?
Yeah. So in automotive, I'll start with a very usual problem which I face every weekend. So every weekend, Sunday in Germany, everything is closed except the restaurants. Even the parking lots are closed. So every Saturday, I have to manually go into maps and find out the parking lot which would be. It's the same query every week, but somehow my phone cannot remember that it's my same preference. I can remember it would have saved me the manual effort, and so many hours. It takes me around 30 minutes to find such a parking manual.
Right. That's one difference. Other thing is the fact that on weekends the parking lots are not available. So that particular fact is not available in this entire flow.
Right.
It's a very small example, but there could be like other examples also around this one. Right? Going ahead, the second problem which we have is, which we face is orchestration problem, right? And this is basically where when we hit the roadblock, we also try to understand the patterns in the system, and we got to know that there has been already some research done on that. So what does that mean? If your system has like one to three tools between which you have to do orchestration, it will work very, and that's actually demo editor, right? Most of the demo application which people see in B2B industry, and people get excited, oh, it's working very well. Those are the those one to three tools are being used there, and that's why that's not the ideal criteria to judging a platform or judging a product, right? When you go ahead with 4 to 6, 7 to 10, 10 plus, then problem starts surfacing, right? In Wino, we specifically hit the roadblock on the 7 to 10 tools. Actually, we started from there. Okay, not even that. Actually, we started with like 40 plus tools, which we have, which is like required in particular in data science. And when I say this roadblock, it means like you will say like what is the 70% overall thing. So this is basically the outcome which from the entire system. Okay? So more and more tools you will put, less and less outcomes you will start getting. Okay, so maybe one or two tools will work perfectly, but other tools will start hallucinating. So, okay. So third thing is action gap. Actually, I already talked about this one, but this will I'll cover. So action is like, okay, I'm good in giving you your answer to your query, but what about acting on that, right? So let's say, well, I can give one example of automotive, which I worked in when I was in Harman. So in that example, so basically, let's say you are in a vehicle and you want to go from one place to other place, which is like, let's say 50 kilometers. At the same time, your vehicle fuel level is low, which can take you hardly like up to months, right? So vehicle should have, or agent should have that intelligence that it should take you via a place where you can fill your tank, right? So
that's the human intelligence as well. You would have done it.
Right? Similarly, in BFSI, if I talk about any example, so basically, this thing, it will tell you that the lead score has been dropped, like there has been less conversions and all. But what needs to be done on top of that, that is the real intelligence. That is something plain LLM and the AI apps will not be able to do. For that, you need persistence layer, action layer, and other things, right? Okay. So basically, yeah, so let's tell you.
Yeah. So it's the same architecture problem with higher consequences for automotive. Reason is in automotive, if something goes bad, there is harm to physical human. And then eventually there are lawsuits and then that's why the consequences are very high. And in automotive, the latency requirements are too stringent. You have to act on certain sensor input within so and so. For it's a real, in camera use case, it's a legal requirement actually. Nothing else. So for us, for the automotive industry as well, it's the same problem, but it has consequences. And there is another caveat. We have to go offline first as our strategy here because vehicle can go everywhere. It can go into a low. So what do you do over there? You cannot use cloud to perform highly level computations. But at the same time, you cannot use your own car completely because it will burn out that SoC. That is the problem which we have.
So a similar example which I was talking about yesterday, in the previous slide, where we were talking about the layers, the different tools and orchestration layer. So if you see vehicle, it becomes more complex because here we have like more than 70 network computers in a vehicle, right? Now think about it. If you go wrong at one place, or if intelligence has to flow from one place to other place, I mean, how long it will take, right?
And contextual aware intelligence. So it's not the same fault which occurred in it is traveling. It is also collecting information on the way and then traveling towards some other way.
So it's very important for orchestration to be like efficient, so that each component knows exactly what it needs to do in a particular scenario, and facts flow faster than anything, right? Okay. So what we should actually build, or I would say what we actually built in my own view, is session memory layer, which I talked about. So session memory layer, basically think of it like we try to understand. I'll do a little diversion here. So best way to learn AI is or machine learning is to understand human behavior, right? More and more you understand how human think, and you will be able to mimic those things into AI more, right? So session memory layer, if I talk about it briefly. So as of today, AI uses memory as a everything or nothing, right? So it has a lot of history about the client and everything. But the thing is, if I have to ask for a specific query, it will actually go through entire thing and then it will come. Unless I give it a very specific prompt. Okay? important. So how human thinks, you just think about it, right? You must have done a lot of things. Like if I talk about me, I've worked with Samsung, worked with Harman, and currently I'm working with I had my own startup. Okay, I have a family, I have friends, right? So if somebody asks me, let's say about, how was it in Samsung? Okay, so I'll not talk about anything other than Samsung. Like I know only that particular part I have to talk about, right? Or someone will say, how's, let's say, so I was earlier in Noida, or let's say Atul in Germany. So if somebody will say like, how the weather in Germany looks like in this month, so he will not think about other parts of countries or other parts of world. He will only think about Germany specifically. Right? So that's how, but machine does not work right. It catches everything, then sort, then sort, then sort. So that's why a session memory layer is one part. I'll explain on this one, where we're doing the knowledge stacking. Like what part of knowledge is for what purpose, and that is actually optimizing our this memory game, and also it is helping us in having the targeted context, right? So similarly, we have built the tool orchestration engine, where we are actually defining a framework which we have built, on which we can define what is the capability of a tool and how the facts will flow into it, what kind of memory tagging is required for that, all those things. Then comes the action layer, where based on these two, it has to act upon something, and those will be defined in another framework. Okay? Final layer is trust and audit layer. So how many of you use Codex or AI for coding? I think most of you use as of today, right? But think about it. How do you debug your code, right? So for debugging, what you put specific logs, spaces, right? And if something goes wrong, you will go through those logs and then you understand. But now think how AI is doing that. AI is basically for AI, it has to relearn everything, it has to understand all those things, right? So what we have built in order to save the time and build a better quality, what we are doing, we are running a parallel agent, which is actually tracing everything what an agent is doing, right? And this is like an auditor agent. And in this entire tracing, anywhere it feels like there is something wrong, it reports and it self-heals. It updates the agent's behavior, right? And that's how we are solving this particular problem. So this is like one level ahead. But yeah, so this is what I wanted to talk about. This is the fourth problem which we faced, where optimization was required, and that's how we solved it. Okay?
The trust and audit layer idea is also very similar to how function safety vehicles actually work. They have something which takes action, then they have a backup which verifies that action. But it doesn't correct it. In our case, our idea is to correct the first level as well as so that the general intelligence is enhanced over faults.
So one clarification here, when we say corrected, it does not correct itself. There is a human in the loop, okay? Because if you give algorithm to AI, the way it can, it will never know whether something went wrong. Because the human in the loop is required for this. Okay? Moving on. So there are some problems we could not solve yet. Okay, we are still working on those things. Okay, where in memory we talked about the tagging and everything, but the abstraction, right? Like the runtime, how we will do this, this tagging and all. So that is something which we are still figuring out. Okay, and then so right now a two-level framework we have built. Okay, but what should be the composition? So it means if for a specific use case, what all tools should be required. So that is something next level we are doing, where it will auto detect that what kind of specific uses, let's say lead management, what all tools will be required and what kind of understanding will be required. So right now we gave out all those information to it manually, and we build it once and it's running. But what our vision is in future, all these things will happen autonomously. Third is trust calibration for agentic action. like very two important things, right? So what we are doing, we are trying to do one level of calculation in that, where human in the loop is required, but less with less information. Fourth thing, what we are doing is the agentic evaluation of benchmarking. So as I said, right now, this one, interest thing, auditing we are doing at our home, right? That audit is not just the, like, something is wrong or something, it's also the benchmarking the capacity of the agent. So what we are trying to do, we are trying to use same flow in order to benchmark all the agents which are there in the system and make operate on
Just my personal take is, as Rahul explained, it's still even in the loop for now, but with less and less information. I believe when that intervention reaches zero, we would have reached a sentient state. Because that means we are now trusting someone, a machine, with money.
Okay. So, I mean, some of the emerging standards in the industry which are already here, as like agent to agent, MCP, OpenAI, agent SDK, Client AutoSolve, we already have. Now, next thing, what and we are also building, we are building like domain-specific orchestration layer. So basically, you can say we are building something like Langara, but specific to BFSI, specific to. So there will be two layers now. One is agentic, which is Langara already. On top of that, there will be one more layer, which will be domain-specific, right? And there will be a interface which will connect these two, right? So tomorrow you can replace this domain with any other domain, right? So that is something which we are building here in Maya. Okay. So what is missing is what is universal agent state format. So basically, yeah, as I said, the state management persistence layer we are already doing. But one thing is still missing, where for us human there is few things which are like global truth, right? Right now we are not sure what is that global truth for in terms of agent, especially in our domain. We don't know, and that is something which we are working on, which we are researching. If I tell you about the research opportunity which is there, the one is the formal verification of agent flow. So right now, a lot of manual work, a lot of calculation work goes into this one. So there is definitely requirement of a formal framework into that, right? Memory. So we know that memory, more and more agents will become more and more memory required. So how can we do the compression of that memory, right?
And just to word on this memory compression topic, it's really important because we are right now facing a scenario in automotive, because the memory SSDs which are getting manufactured, they are moving towards data centers. The industry is actually running behind. They are having to face higher costs just to procure the same SSD part as the data center. So it's a very real problem, and I think we would have unpacked the in-series from HBO, Silicon Valley. It's built around that app which does just this memory compression. It's that important.
So other thing which is very important, and actually we are actually doing some very high level research on this one, is human agent teaming of protocol. So right now human in the loop is there, but the collaboration does not have any formal standard or formal protocol. So what we are doing, we are trying to come up with a protocol which will solve this problem. In fact, one of the protocols which we have already written here was how to reduce in this line only, how to reduce the consumption of token, right? So that we are going to finalize it and we'll share with everyone. One more thing, I would say where it's not part of this thing, but overall where industry is shifting is, so earlier many of you would have heard about the dashboard report. So basically your exam report cards, basically. So what exam report cards tell you, it tells you got this mark in this subject. But it does not tell you the insight. For insight, you need one expert who actually understands your learning pattern, who understands your basically subject pattern and everything, and how how you have been taught on these things, or your classes pattern on these things, right? So industry is moving from dashboard to insights, right? You will see less and less of dashboards, and you will see more and more insight platform where people can simply query the insight, query for the insight without asking for those big dashboards. Okay, and that is another thing which we are building here. Okay, so what's for you guys here? So one thing is we defined 4 problems, right? 4 open problems which we are still working on. So I mean, feel free to go ahead and work on those problems. Definitely, it's a very exciting era. A lot of opportunity. I compare this era as like when computer revolution happens and companies like Microsoft and Apple came, and next then .com revolution happened, and at that time companies like Amazon, Google and Meta, all these companies came. Then mobile revolution happens, and then at that time Ola, Uber, all these mobile apps came into picture. Now this is basically the AI era, AI revolution, where you can, and it's very easy to get into this one. So till now, I would say AI was being discussed since last more than 20 or 30 years, different since decades. But entry variant, there was a very high entry variant to this one. With the introduction of so many like these LLMs and so many tools, it has become very easy to enter this particular domain. And I really think we all should leverage that. You all should leverage it. So yeah, that's my time. Thanks for your time. Thank you.
Okay, have they completed? Thank you so much, sir, for your so much deep insights into the LLM problems and the other issues and the areas which we are going to focus in the next coming times. And as we know that how the science is actually gaining from AI and how we are actually losing to AI as well. So these are some of the genuine problems which are being concerned over, and I think over a period of time, something new, more better solutions will definitely come up. Thank you so much, sir, for your presence. Now we are moving to our next expert, Dr. Bui Than Hang. He is joining us from very much Vietnam. Is he there? Okay. Let me give a brief introduction of Dr. Bui Than Hu. He is a faculty member, Department of Data Science, Faculty of Information Technology, Industrial University of Ho Chi Minh City, Ho Chi Minh City, Vietnam. So we are waiting for him. No? Dr. Bui Than Hu, are you there online? Is he there?
Yeah, I'm here.
Okay.
Sorry.
Welcome, sir. We are very much privileged, and Scope Global Skills University wholeheartedly welcome you for this expert talk session. Let me introduce to our stakeholders that about a brief introduction about you. Dr. Buitha, who holds a PhD and serves as a researcher and educator at the Data Science Laboratory, Department of Data Science, Faculty of Information Technology, Industrial University of Ho Chi Minh City, Vietnam. His research interests span a broad and interconnected range of AI and computing domains, including natural language processing, machine learning, deep learning, machine translation, text processing, data mining, image processing, voice recognition, and artificial intelligence, reflecting a profile firmly rooted in the practical and theoretical frontiers of modern data science. His work in NLP and machine translation is particularly relevant in the Vietnamese and Southeast Asian language technology context, where low resource language processing remains a significant and impactful research challenge. Combined with his expertise in voice recognition and image processing, his research addresses real-world AI applications across multiple modalities. As a member of the Data Science Laboratory at IUH, he contributes to both advancing research and shaping the next generation of data science and AI professionals in Vietnam. We welcome you, sir. Now the dais is given to you to give your presentation and insights on artificial intelligence.
Okay, thank you for your introduction. Can you use my board?
Yes, sir, your presentation is visible to us.
Okay, thank you. And today I'm very happy to present you the research of persistent prediction model using deep learning and machine learning framework. I'm Buitha from Data Science Laboratory, Data Science Department, Faculty of Information Technology, Industrial University of Ho Chi Minh City. And here is the outline of my presentation. First, I will talk about introduction and some related work. And after that, I will present our proposed method, some experiment, and lastly, I will conclusion. Now let's start with introduction. What is toxicity? Toxicity means that the property of being poisonous or causing an adverse effect on the living organism. So there are many common chemical hazards in the workplace. You can see here, for example, acid and solvents, cleaning agent, glue and paint, heavy metal, pesticide, and other toxic materials. And here is structure of mycotoxin from chemistry.com. You see as a very complex structure. And what I did, computational chemical biology, you can see that we will apply in many toxicity here. For example, B toxicity, fire toxicity, rhodis toxicity, X7, and another toxicity. There are a lot related to toxicity. So, almost methods focus on using machine learning and deep learning for toxicity prediction. And you can see here overview about the method to solve the toxicity prediction problem. From the toxicity data, for example, here is toxicological data. We build the chemical data. And also in monkey omic data, and from this data, we will apply first we will reprocessing and also check the picture and apply the machine learning and deep learning approach to prediction to predict. For example, here you can see we can predict the drug toxicity or another prediction. And we will use the result to build the application. For example, boosting the clinical application doctor on another application. We can use this data. And this research have many applications. We can apply drug discovery and development, environmental risk assessment, regulatory compliance, Also, we can apply in the chemical safety evolution and academic research also apply machine learning and deep learning for 260 prediction. And there are many deep learning or also machine learning approach apply to system prediction. You can see here, for example, for acute care to system with some research focused on runoff rate, FVM, background, and another approach. And you can check more detail in Chance and 2025 to know overview about how machine learning and deep learning apply to the system prediction. This is research because we focus on some revision approach. Who had only in 2023 they propose review of machine learning and deep learning model for persistent prediction. And recently, some research focused on FISMO, Garan, and they propose meta learning approach for future learning, a survey of recent advances. Meta on the propose and mapping to molecular classification using the neural network and future learning. And to rest alone, they propose rethinking transformer with comparison and embedding of future molecular property discovery. And also recently different with other. First, from research, we will choose the good way for research. First, we propose the BRMGD model with a lot of the brand design to effectively leverage information from the company using molecular replacement in computational biology, for example, Morgan fingerprint, a smart sequence, and molecular graph with a brand 1 fingerprint LNP, brand 2 GCN encoder, and brand 3 sequential ECNN. Here is the overview of our proposed method. First, from the fingerprint, Morgan fingerprint, we will apply LNP to get the structure and chemical motif. And with the molecular graph, we will apply GCN encoder to get the structure and atomic interaction. And for the smart sequential, we apply the sequential DCNN to get the sequential pattern from canonical syntax. And we will concatenate three features here and apply to meta learning by pro-high neuron fusion learning to prediction, to predict. The first with the finger LNP branch, and you can see more detail what is the finger LNP branch here. From Morgan fingerprint, we will apply the linear, relu and linear to, it means that this is the LNP branch for to get the picture with the embedding 128 dimensions. In a first brand, we just apply the LNP, the simple structure for the first branch. And here is the figure describe how to get the drug molecular from the smart to graph. But we have smart structure here, and we will graph the drug molecular, and after that molecular graph, we will apply the graph convolution neural network for brand. And also with this brand, we have the embedding with the same dimension as prevalent brand in. Here we apply graph comparison neural network for the second brand. This is like describe more detail how to get the feature from the graph neural network. In the graph neural network, we define the embedding node. It means that here we had a horizontal network and we will apply the embedding space. It means that we had to define the similarity function to embed from the horizontal network to the new space. We then apply the shallow encoding. How the shallow encoding had several limitations. For example, parameters are needed inherently just a key and do not incorporate node feature. And so here we apply the embedding node. It means that the first we build the graph first. Here we have V vertex set, maybe as a system machine, and we had a node feature with the categorical attribution, type image data, node degree, clustering coefficient, indicator vector. And first, we will do the neighborhood prediction. The key idea here generate the node embedding based on local neighborhood. Since that we had layer 0, means that the horizontal network, and how to build the layer 1, layer 2, and more layer in the deep graph neural network. The idea here is very simple. We generate the node in the hidden layer based on local neighborhood. The first, we calculate every neighbor information and apply a neural network. The first, we will calculate every message from the neighbor, and then we apply the neural network. So we will build the graph neural network from the neighborhood aggregation. Here is the formula describes how this model works. You can see that here is in the key layer and here is the non-linearity function, and this is the state 0, means that the integer layer or layer 0 or the node feature. And this is in the previous layer embedding, and here the average neighbor previous layer embedding. So from that we will change the model with the aggregation parameter, and there's some unsupervised loss function can be applied for the changing the model. For example, we can apply random walk, not to back, deep walk, or graph factorization, or we can change by another operacy. So here is the overview of the model design. The first, we define the neighborhood aggregation function. The second, define the load function on the embedding, and then the chain on the set node back that compute graph. From that, we will generate embedding for the node as needed. The convolutional neural network provided given only in 2017, and this is a different with the neighborhood aggregation idea. You can see in the small figure here in the basic neighborhood graph neural network, and here is the graph convolutional neural network. And now you know what is the difference between the graph neural network and graph convolutional network. And in this brand, internet brand, we apply the sequential deep convolutional network for the last brand. From this mind, we want to encode pattern embedding and apply deep convolutional network for this data, and we get the embedding vector. And in the first brand, we do the sequential LNP. The second brand with the graph neural network as with its convolution network, and then we combine the feature from the data set, and we apply the few sort classification for the content division feature. You see that here the zero sort prototype, and here zero sort in the figure B, and few sort prototype in the figure A, and few sort have many advantages compared with the zero sort. And for the zero sort, for the few sort learning, we will prepare the data and chaining process for each step. With the data set, we do experiment on two data sets. The first is cider, and the second is TOSIP21 with the chain test and increase combo as shown in this slide. And we evaluate by 5 metrics here out of precision, equal F1 score and accuracy. And we get the result in more detail with the 5 sort in the cider and TOSIP, and also in 10 sort in cider and TOSIP21 in the AROC F1 and accuracy with the data here prediction toxicity pattern prediction. And you can see that when we apply here in the P3 or D3 the result compared with the and we compare with recent research. The first thing we compare with research in 39 and 23, and also our research here. It means that we compare with advanced research in recent year in the related work I just showed you about the here in the research we compare with Dr.Ramesh in pattern recognition in 2025, and we saw that our research got better result compared with previous research 23, also 39 in 5 sort and 10 sort. And we visualize the AROC score for our own comparative model of the test set in the 5 sort and in the 10 sort. And you see that our model here was a better result compared with other research. And also we compare with some graph neural network to evaluate your proposed graph convolutional network is better than other or not. And you see that here with some graph neural network here, result in 40 with meta ZNN, 41 with 3 ZNN, 42 EZNN, 43 MALN, and 44 with 7 to 7. And our research, our proposed model here. And from this result, you see that our proposed model got the result and other graph neural network. It means that your proposed graph convolutional network work well on this model. That's why our proposed method got a better result. Also in 5 sort and 10 sort, you can check more detail here. And so I just present with you our proposed method, the NCD model. This is integrating multi-layer system, LNP, one-dimensional convolutional neural network, 1D CNN, and graph neural network, and also prototype network method for chemical compound toxicity prediction. This integration, this perspective within fields of learning setting and after framework to quickly adapt to new toxicity task with the limited supervisation, making it especially well suited for real-world sesame with the limited data. In the future, we will refine the architecture, explore more advanced feature within the security, and we will integrate multi-dimensional data source. With this research, we had one published paper in Young Scientific Conference in 2025. We got the best poster award. And also we had one revised papers submitted to SCI P1 journal. And this is the second round for review. If you interested with our research, you can check more detail on my website here. My research topic: natural language processing, machine learning, machine translation, text processing, data analytics, computer vision, and artificial intelligence. Thank you for your attention, and I'm very happy if you have any question. Here is my personal website, and you can check more detail from my personal website here.
Okay, thank you so much, sir. Thank you for your deep insights, and I believe that the stakeholders and the students and many other delegates who are listening to you from the different length and breadth of this globe might have enriched themselves, and they will definitely connect you. Thank you so much, sir, for your august presence. Thank you for joining for this international conference on emerging trends in artificial intelligence and joining for the Scope Global Skills University. Thank you so much, sir. Thank you. Now we are moving to another speaker who has given the recorded one, that is Professor Dr. Abdus Samad bin Hassan Basari from Malaysia. So we are going to play his recorded version of the audio video that he has sent to us, and let me give a brief introduction about him. Professor Dr. Abdus Samad holds a bachelor degree in mathematics from UKM, Malaysia, a master's in information technology from UTM, Malaysia, and PhD in information and communication technology from UTM. He is a full professor at UTHM, currently serving as the head of the Soft Computing and Data Mining Center and principal researcher at the Artificial Intelligence and Data Mining Center. His field of specialization is artificial intelligence and predictive analytics, with active research in machine learning, data mining, soft computing, healthcare informatics, digital transformation, and smart system. He has led and contributed to numerous funded research projects spanning flood disaster analytics, fleet routing optimization using reinforcement learning, LOT-based livestock management, business intelligence using blockchain, and augmented analytics for ICU admission prediction. He has published in international journals including Personal and Ubiquitous Computing Springer, KS2 Transactions on Internet and Information System, and IEEE conference proceedings as well, with research outputs covering face detection, trauma classification, digital transformation, cloud computing adoption, and software product line testing. He is an active PhD supervisor and external examiner across multiple Malaysian universities including UTM, UTP, UITM, WUM, UIAM, and UPSI, reflecting his standing as a trusted academic evaluator at the national level. He has also delivered international keynote talks in Indonesia and serves as a visiting professor at University of Polytech, Malaysia. Now we are going to listen to his in audio video that he has shared with us. So we will just confine it. Okay.
Thank you for having me to my speech on this conference, which is entitled From Data Acquisition Scaling Really Impact Across Business and Industry. Again, thank you very much for the conference committee and organizer accepting me to be one of the keynote speakers. First of all, I would like to apologize for not attending physically. This was I'm going abroad at this time.
call it as the set of AI.
बंद कर दे
Then the title that I choose is on the evening, which is a subset of the image of the STI. So this is the some sort of hierarchy of deep learning technique. And starting from generative, discriminative, arrestive, and so on and so forth. And this is one of the architecture related to this deep learning. Starting from input, for example, an ordinary image from some sort of layers until the output that we expecting. So how deep learning support decision making? So of course we can recognize from the list data sets, and also we can have real-time forecasting, anomaly detection, and prediction as many more. And this is why visual analytics in deep learning is very important, because they can help in many things, as stated here, why, what, when, who, how, and where it can be applied. So this is basically the application of deep learning. Then there are many more, from self-driving cars up until actually here listed. Then okay, let's look into where it's been used as a case study, static analysis on social media, customer segmentation, personalized recommendation. So here we can have a kind of studies related to this, and based on this we can for example, static analysis on social media. We have many issues now, especially related to network wars between Israel and Iran in the Middle East. So might be there many information which is whether it's fake or correct in social media, so that we can perform a static analysis to look into that. So as well as customer segmentation, we have a feedback from customer on the might be related on product review, personalized recommendation on movies, Netflix. So based on the review from the users, so they can give rating and so on. So then from there we can also subscribe to this Netflix. From the recommendation from this user. So then finance and risk, so especially in banking system, in many things like fraud detection, so whether they have when we talk about the finance, money and so on, so there are so many scammers right now. So maybe from this we can look into how to prevent this being planned. And so the credit scoring models is things that most want to lend money and then to might be able to buy a house. So then of course we look into whether the capability of the applicants to maybe to have a loan to bank institutions. So based on this we can have the scoring, credit scoring. So then of course we have to trading strategies for those who want to go to trading, want to go to stock exchange and so on, right? So operation and supply chains, of course, they also is very important, especially on big scale, high scale, and also sophisticated in terms of operation and supply chain. So we need to have this strategy to make lots of marketing and sales.
So we have a kind of a campaign, optimization, deep learning, deep scoring model, dynamic pricing strategy. So anything is related to this will, deep learning might help as long as there are data to be analyzed as well. So this kind of architecture and tools are related to deep learning, and of course with challenge and implementation, data quality, mobility, high condition requirement, model scalability and trust. So it's a few challenges that need to be considered in order to implement this. So ethic and bias, of course, is also again very important, because when we look into the training data, the fairness, and then the compliance, you need to comply for this in order to make sure that the learning that we use is accountability, being accounted. So this is a future trend. Of course, we can talk about the explainable AI. It's not only in the black box, so there must be something that can be explained in terms of many things. Real-time decision system is very important, and integration with IoT and HI. So key takeaways. Of course, we know that deep learning enables smarter data-driven business decision, and then the success depends on data, tools, governance, long-term competitive adaptation, so on. Right? So this is things that we need to also consider. Right? So then, at the end of this presentation, I would like to share one of the studies that we did on human resource profiling. So we have the signature identification through deep learning. So this is the chronological of the identification, starting from 90s, 80s, from the conventional road up until to have the LSN as part of the models on an algorithm in the deep learning. So this is the process, signature, and then from this signature is an input, and then we have to process the data set training and the output. Based on the output, we get the facility based on the signature. So then we get then based on the data or the recorded signature belong to what, or signature is them for what kind of profile. So then we also verify from expert to confirm that consent, so to confirm that this is carried for this for the use. So this is one of few example. For example, realistic. So a kind of roller code, reality, personality, is practical, down to earth, enjoys connectivity, carpentry, carry parts and mechanics, like this hands-on work, investigative, sanity, enjoy working with outside. It might be something you feel like researchers, so might be this kind of. And then artistic, creative, imaginative, and have a strong vision on aesthetic. So there's the result performing writing, like might be artists, right? Might be they have the script writer, and then social, or we have the enjoying others, counseling work. So might be influencer, might be, right? And then enterprise, of course, this is for the entrepreneur. And then conventional, like might be is on the administrative position. So before the end, this is few response that can be read and considered. And so I end my record here. Very much thank you for listening. This I think it is quite short in terms of the presentation, and hopefully, if anything, you can contact me on the email to get further clarification, further discussion on this topic. Thank you very much.
Okay. Thank you, sir. Now let us start with our online presentations. So the first name is Paresh Kumar Ravindra. Is he with amongst us? Yes.
My presentation is visible.
Yes, yes, your presentation is visible.
So, good afternoon everyone. I am Paresh Kumar Prajapat from MP Institute of Computer Studies, Bharuch, and a research scholar at Dr.Ramesh University, Baroda. Today I will present dog skill entity recognition, a custom entity annotation using try structures for automated reasoning analysis. Now, the problems and motivations. Domain-specific named entity recognition in computer science remains unexplored. While NER has advanced in general application, the recruitment domain faces three key challenges. First, resumes are unstructured. People write skills in hundreds of different ways, ML versus machine learning, Python programming versus Python. And second, new technologies emerge constantly, so any system must handle unknown entities, not in any predefined data. The third challenge is this: existing approaches typically handle only known entities. So solution is JSER addresses all three using try-based matching for known entities and POS tagging and context analysis for unknown entities and achieving the result 92.08% of accuracy. Related works and research. Existing approaches have limitations like SVM, ANL can't extract individual skills. Similarly, fast and has no hierarchy. By LSTM CRF needs large level data. CRF benchmark only reach F1 of 0.59. The gap is none can handle both known and unknown entities without large labeled data set. So JSR fills this using try plus POS tagging instead of supervised machine. System architectures and pipeline. JSR processes resume through a 5-stage pipeline. Start with a raw PDF extracted using PyPDF2, then tokenize and POS tag with natural NLTK libraries. Then text normalization has two components. The lematizer converts word to a base form. It processes 5,000 words from 150 resumes. The root word extractor, that is RWE, strips affixes like programming becomes program. For entity matching, we use a try data structures. This is key. Try gives OL, lookup where L is just the string length versus the linear search where L is the data distance. Now, entity detection, that is known and unknown. JSCR handles two types of entities. For known entities, we build a hierarchical try taxonomy. 105 skills, 1052 skills across 52 categories and 122 subcategories. Categories are split into subcategories. For instance, JS underscore PLD, that is job skill underscore PLD, that is programming language and technologies, is split into two parts. That is JS underscore PLD underscore FE, that is for front end, and similarly JS underscore PLD underscore PE, that is for back end. So predefined entities are matched and tagged. For unknown entities, the harder problem is here. Use a compiler design concept, lexical and synthetic analysis, and the sliding window of size 5 captures 2 words before and 2 words after the tag. We tested the sizes like say 5, 7, and 9, but we feel that the size 5 was optimal. Larger windows was introduced a noise. So context-based extraction uses proximity to known entities for infer categories. Also, HTML captures sequential dependency for robust annotations. Evaluation and results. GSCR achieved 92.08 overall tagging accuracy. So exactly 4608 corrected out of 5,000 words from 150 resumes. The lematizer identified 396 incorrect or missing entities out of 5,000 processed words. POS tagging was evaluated individually for pronouns, verbs, and nouns. 4 key advantages. Try gives order of magnitude speed improvement. Dual detection handles both known and unknown entities. Modular design means the system can adapt to healthcare, law, or finance or any domain. And we build a class web interface for practical use. Now the last slide is conclusion and future direction. To summarize, JSCR provides a novel domain-specific NER algorithm with a try-based taxonomy.
Okay, thank you so much, Mr. Paresh Kumar Prajapati. Now we are moving to our next presenter, Mr. Prabjot Singh.
Thank you. Can I share my screen?
Yes.
Is my presentation visible?
Yes, it is visible. Kindly make it to the full screen.
Okay, so my presentation topic was artificial intelligence in visual art practices, contemporary application structure limitations, and implications for future artists. I have tried to focus on my research that it is not entirely on the technical base of artificial intelligence, but rather on the humanistic values that are aligned with it. So the research findings came out to 6 possible things that we should really focus on. The one was change in art field, the second was similarity to dot-com growth. The third was the unsustainable growth of AI ecosystem. Fourth was impact on creative labor, and fifth was the further impact on artists themselves. The last was possible collapse of the ecosystem that is currently available, not the entire ecosystem that is helping really AI. So if we really focus on the first part of the findings, it was the change in artistic field. If you focus there, you can see there are 2 images right now. If it was to be developed by the traditional way of making art, as in 3D, we would have used software like ZBrush or Blender, and these softwares, while using it, require artistic skills and human input, a lot of it. And it would have taken 4 days to complete a model like that. But with artificial intelligence, it has been created by 4 to 5 days. Such fastness and rapid development of ideation can lead to downsizing of workforces, and it is estimated by 2030 at the earliest, about a lot of jobs will be downsized, and a lot of jobs, when I'm saying this, is majorly focused on creative industries like illustration, animation, music, and writing. And for another example, let's just focus on illustrations. If this was to be illustrated by an artist using Photoshop, maybe, it would have taken, I think, a week. But AI helps you not just create it entirely, but if you just give it a base, AI will fill in the different parts of it and help regulate and fast track the workflow that was once taking a lot of time. Thus, it saves money, but it also creates the impact that the artists that were working on it now can create multiple projects at the same time without losing their times. It is also going to affect the impact. The impact of it will also be on creative labor. As such, Anthropic, the company that has created the artificial intelligence, a lot of people might be using it. It has given out the research. In that research, they gave us the data on which industries are going to be really impacted. And if you can see in the diagram, the art and media industry, the theoretical coverage of AI is about 80%. That is where a lot of predictions are being made that major jobs will be lost. But the current observed AI coverage is only about 10 to 20%. Thus, the current phase is more or less people doing it and not realizing that AI is really going to be consuming a lot of jobs. And 90% of the teams that are currently being used will be downsized. For example, if there were 100 artists that were creating a movie, we could possibly see a future where 40 to 50% of those artists will be gone and 2 to 3 member teams will be replacing them, and they are going to work on the same movie and create it maybe faster. It had maybe faster. Thus, it is also really going to show impact on artists themselves, because making art so easily accessible, a lot of artists that are not untrained will be reaching into the field, and once they enter the field with not the classical training, the values that have been developed over centuries by artists and over they have practiced, a lot of things, the movies and the artwork will lose the humanistic touch or the humanistic values that really make them special. They will start feeling maybe robotic, and that is where the artificial intelligence bubble. It was a comparative study of economical and legal dimensions. We came across that during the period of late 1990s, adding zero.com suffix to the company's name was attracting a lot of attention and investments from the market. Thus, a lot of companies just came about and started using that as a way to get evaluation and boost their profits. Now, I'm not saying that AI is doing the same, because AI is based on a lot more stable and working ecosystem, and its usage is entirely foreseeable that how it's going to develop in the future. But right now, when we really compare it, during January 1995, you see that shows that index grows really rapidly in the next 5 years, and then automatically in the next 2 years, we saw a fall. Same thing seems to be happening right now with the AI, where index and the investment in US billions seems to be increasing over and over. It showed a slight dip in 2022, but during 2023 and 24, it has rose again, and it has rose by a significant margin. A lot of these companies go about and have developed their CEOs as celebrities that showcases that their model is going to change the future, but they are not having a sustainable growth, and their companies are not running in a way that they could sustain it in the long term. And to keep that point running, a lot of companies, when they start, according to Economic Times publishing of 2017 or 18, they showed out of 11 companies that start, only 7 survives. So, keeping in that mind, when we see the economic data that we have gathered for 2024 fiscal year, a lot of companies were having losses even when they were doing better than their last year. 3 examples are OpenAI, Anthropic, and Zoho. OpenAI lost about $4 to $5 billion in 2024 in losses, and Anthropic was $5.3 billion in 2024, where Block was losing about $1.2 something billion every month, making it up to $9.8 billion by the end of 2024. Globe having a big backup because of Elon Musk and X, formerly known as Twitter, can sustain this, but companies like OpenAI and Anthropic are just out there having their evaluation and getting the investments to keep the companies running, which is not that sustainable. If we really see their spending distribution, this is roughly the 3 areas they spend the most on. One is cloud server. Cloud server is not exactly entirely taking their $1 billion from them. It's taking about $0.81 billion from them every month, and then there is server costing. They use Microsoft servers majorly. That is taking about $3.4 billion of their entire monthly expenditure, and then there is infrastructure. By infrastructure, I mean NVIDIA. NVIDIA is the only company currently right now that is making profit out of it, and most companies are spending about $4 billion every month to maintain their infrastructure, to keep their AI platform running. They are not really running in a sustainable way that they can win this through the next year or the next decade or so. The unsustainable growth of artificial intelligence is not only seeing their bad economics, but also that they are consuming roughly up to 3.125 billion to 764.6 billion liters of water in yearly. It was in 2025 they consumed this much, and US data centers have estimated to use alone 17 billion gallons of water. 40% of US data centers located in the areas that have electricity, and it is due to that their high consumption of water has led to it. It has placed a significant strain on local communities and resources, which does affect the people that are living around. And global freshwater consumption, approximately by humans, is 4.3 trillion cubic meters, which is 1.14 trillion gallons roughly. If we go back to our units, it's not that different. Agriculture consumes what? Agriculture consumes 72% of it. So humans are not entirely consuming it just for manufacturing. Agriculture needs a big portion of it. Thus,
Prabjot, please summarize your presentation. It has already been more than 5 minutes, okay?
Yes, I'm just summarizing. The development of RAMs and AI chips seems to be taking a huge role in real metals and metal consumptions, which has led to long-term financial unsustainability because the increase in demand has led to increase in their prices. In conclusion, I believe that current AI systems and models are not really sustainable and are really profitable and model-driven, which will not be able to sustain themselves through this last decade or so, and there will be a collapse, the same collapse of ecosystem like there was for .com bubble, and at the end of which we will be able to see a new rise of platforms that will be more human-centric and will not overtake humans, but will be helping us as our assistants, and the authorship of the articles that will be created will be dependent on humans rather than by machines that are creating it. Thank you.
Okay, thank you so much, Prabjot. Now we are moving to our next presenter, Anisha. Is he there? Anisha, can you listen us? Anisha is there? Anisha, can you hear me? नहीं है. Is Samiksha is there? I think there is some problem, technical problem with Anisha's from her end. Let us check it. Okay. Is Ashwani Bess? Ashwani Bess?
Yes, ma'am. Yes, ma'am.
Okay.
Yes, ma'am. May I share my screen?
Yes.
Is my screen visible to everyone?
Yes.
Good afternoon, respected chairperson, distinguished scholars and fellow researchers. Today I am presenting my shaping cultural identity, moral values, and social structures. In the contemporary digital era, the rise of artificial intelligence is transforming the ways in which cultural narratives are produced. AI-driven tools such as generative AI models and algorithmic storytelling systems are increasingly participating in the creative process. As a result, mythological narratives are being visually and narratively reconstructed in digital spaces. My research argues that artificial intelligence functions as a cultural mediator that connects ancient mythological memory with contemporary digital imagination through AI-mediated media arts, mythological vision, and no longer confined to fixed archetypes. Thank you, and I look forward to sharing my findings with you. Title: Artificial Intelligence as Cultural Mediator, Media Arts, and the Digital Reimagining of Mythological Memory. I am a research scholar in Technology University. Overview of conference explores intersections of artificial intelligence, culture, and mythology. Focus on digital reinterpretation of mythological women. Combines cultural studies, media theory, and gender studies. Examines visual arts, narrative reconstructions, and algorithmic storytelling. Highlight ethical and cultural implication of AI-mediated representation. This research lies at the intersections of technology, cultural studies, media, arts, and background of my research is methodological narrative shape cultural belief and social values, women portrayed through symbolic roles. Digital technologies transform storytelling traditions. Artificial intelligence introducing algorithmic creativity creates new possibilities for reinterpretations of mythological characters. These reinterpretations reflect the gender norms and cultural expectations of the societies in which the myths originated. In the digital era, storytelling traditions are undergoing significant transformation due to generative images, narratives, and artificial problems. Traditional myths often present limited repetition of women, patriarchal interpretations, dominant historical storytelling, digital technologies, reshape narrative authority. AI may either challenge or reinforce gender stereotypes. Need for critical study of AI-related mythological narratives. This research therefore investigates the role of AI in reshaping mythological narratives and examines whether digital technologies can provide more diverse and empowering portrayal of mythological women. The objective of my research is examine AI as a cultural mediator in digital storytelling, analyze reinterpretations of mythological women in media arts, explore feminist perspectives enabled by AI creativity, investigate ethical issues including algorithmic bias. The primary objective of this study is explore the role of artificial intelligence as a cultural mediator in the reinterpretation of mythological villain. The research aims to analyze how AI-driven media arts contribute to the visual and narrative transformations of mythological characters. It also seeks to examine how feminist perspective can be integrated into AI-generated storytelling. Research question. How does AI influence reinterpretations of mythological women? What role does algorithmic creativity play in cultural mediation? Can AI support feminist reinterpretations of mythological narratives? What ethical challenges emerge in AI-generated mythology? The study is guided by several key research questions. First, how does artificial intelligence influence the representations of mythological women in digital media? Second, in what way does algorithmic creativity reshape traditional mythological narratives? Third is, can AI-generated storytelling support feminist reinterpretations that highlight female agency and complexity? Finally, what ethical challenges arise when AI systems are used to reinterpret culturally significant narratives? By addressing this question, the research seeks to understand the broader cultural impact of AI technologies and their role in shaping the contemporary interpretations of mythological stories. Role of mythological women. Female figures embody moral and symbolic meanings. They represent devotion, strength, and power and the transformation. They also reflect societal expectation about femininity. Mythological women therefore serve as an important cultural symbols that embody both admiration and anxiety about female power. Analyzing this representation allows scholars to examine how myths contribute to shaping gender ideology in different cultural contexts. Some examples of mythological women: Sita, Draupadi, Urmila, Subnatha, Kuruvin, Manika, and Ahalya. Actually, the topic of my thesis is contemporization of mythological female figures in the novels of Kavita Pandey. So I took female figures and I relate it to AI. Digital transformation of myth. Digital media reshapes storytelling formats. Myth circulates globally through online platforms. Visual culture becomes central to myth reinterpretation. Digital technologies enable artists to experiment with visual style, interactive storytelling, and multimedia narratives. As a result, mythological characters are being reimagined in ways that reflect contemporary cultural concepts. Artificial intelligence in media arts. AI generates images, text, and narratives. Machine learning analyzes large cultural data sets. Artists collaborate with algorithms in creative processes. Artificial intelligence has emerged as a powerful tool in digital media arts. AI systems can generate images, text, music, and and animations by analyzing large datasets and identify patterns. Artists and designers increasingly collaborate with AI technologies to create experimental artwork that combine human creativity with algorithmic processing. This collaboration challenges traditional definition of authorship and artistic originality. Conclusion. AI reshapes representation of mythological women. Digital media enables new feminist perspectives. Ethical AI design women's contribution. This research concludes that artificial intelligence has significant potential to reshape cultural narratives and reinterpret mythological women in empowering ways. However, responsible technological design and critical cultural awareness are essential to ensure that these reinterpretations remain respectful and inclusive. Thank you.
Okay, thank you so much, Ashwini. Now we are moving to our next presenter, that is Anisha. Anisha, are you there? Anisha, can you hear me?
Anisha, your screen is shared. Please open your presentation and start.
Yes.
Anisha, you are not audible.
Anisha, we cannot hear you. Your presentation is there on the screen. Yes, now it is audible. Yes. Yes, please start your presentation and make your presentation a full screen. Yes, it is visible. Make your it is visible. Kindly make it in a full screen, okay?
Okay, ma'am. Is it okay, ma'am, now?
Now it is not visible. It is having some glitches, technical glitches. Yes.
Okay. Is it okay, ma'am, now?
Yes.
So I'm thinking of what title to be clear procedure. This generation. So on automatic paper generation technique of intelligence. So these are so the problem statement
Anisha, we are not able to get your voice clearly. Okay, I think there is some network issues with you. We are just holding up your okay, we are just holding up your presentation right now. We will be moving to the next presenter, okay?
Next presenter.
Next is Vipin Bansal. Yes, yes.
Yeah. Okay, very good afternoon. I'm Vipin Bansal from Rabindranath Tagore University. My topic is review and analytical assessment of Moringa phytosan beans for sustainable wastewater treatment. Coming to the table of content, first I would be discussing about introduction, then literature survey. After that, methodological approaches would be discussed, and then I'll be presenting conclusions and then references. Coming to introduction part, water pollution from domestic, agricultural and industrial activities is a major global environmental challenge. And we know that conventional wastewater treatment that uses inorganic coagulants such as aluminum sulfate, ferric salts and synthetic polymer flocculants. And these chemicals can cause residual metal contamination, toxic sludge generation and potential health and environmental risk. Therefore, natural coagulants and biodegradable absorbents are being explored as eco-friendly alternatives. In that, I used Moringa oleifera as a promising natural coagulant due to its low cost, availability and high coagulation efficiency. And chitosan is a biodegradable biopolymer with strong absorption capacity for various pollutants. Combining Moringa and chitosan in composite bead form enables both coagulation and absorption, finally improving pollutant removal and recovery. So this study reviews existing research on Moringa chitosan beads to guide the development of sustainable wastewater treatment technologies. So these are the literature survey which I went through my studies. Coming to the next slide. Coming to methodological approaches, Moringa chitosan beads are typically synthesized by dissolving chitosan in dilute acetic acid. And then Moringa seed powder or extract is then incorporated into chitosan solution. Finally, Moringa chitosan beads were formed using ionic gelation in alkaline or multivalent ion solutions. And then chemical cross-linkers such as butadiene or genipine are sometimes can be used to improve bead stability. Characterization methods such as FTIR, SEM and BTT surface analysis can be used to study characteristics of the beads form. Experimental evaluation is usually conducted through batch absorption test or jar test experiments. Performance can be measured based on turbidity removal efficiency and absorption capacity. And then absorption isotherm and kinetic models are also applied to study pollutant removal under elaborated conditions. Coming to the conclusions, Moringa chitosan composite beads are promising sustainable materials combining natural coagulation and biopolymer absorption. They keep their function as a single reusable system for wastewater treatment. Literature shows strong effectiveness in turbidity removal. They also demonstrated good potential for dye and heavy metal absorption. However, inconsistencies in material preparation methods exist across studies. Limited research is available on reasonability and long-term performance. And there is also lack of real-world validation or pilot-scale validation. Further studies should focus on standardized synthesis, continuous flow wastewater testing, and life cycle and techno-economic analysis for large scales. So these are the references. Thank you. It's done from my side.
Okay, these are your conclusions. Okay. Thank you so much, Mr. Vipin Bansal, for sharing your presentation with us. Now I am calling Ms. Aarti Singh. Is she there? Okay. Now we can move to Mr. Paresh Kumar Ravindra. He is having his second paper also. Is he there, sir?
Mr. Paresh, please share your presentation. Paresh Kumar Ravid Bhai Prajapati.
Mr. Paresh Kumar Prajapati, please share your presentation. You have requested for your second presentation also, so we are calling up your name. Okay. Aarti Singh is not with us. Okay.
Hello.
Yes. Yes, Mr. Paresh Kumar Prajapati, you have your second paper. Please share your presentation.
My second research paper is about the scheme-to-back, a novel hierarchical embedding algorithm for technical screen representation in automated revision parts. Why do we need a new embedding method? Because word-to-word, fast, text, and flow all fail for technicals. When you query Python in word-to-word, you will think that Ruby, Java, C++, just generic programming language name, which they see two occurrence but miss actual relations. Django depends on Python. That's a hierarchy. TensorFlow versus Python, those are the competitors. Standard models treat all this the same. Skill-to-word capture this concept. Query Python, and you get Django plus NumPy and Pandas, the actual ecosystem. So our data set contains over 2,000 queries and also over 646,000 words and over 50,000 skills. Also there are 226 skills are there. Also there are databases of 10W skills. So skill-to-make is a novel hierarchical embedding algorithm, and it's designed for representing technical skill in visual process. So skill-to-make has four components built on the skill graph. First is SC, that is hierarchical category awareness, is the biggest contributor at 12.4%. It creates learnable vectors for categories and subcategories, pulling skills towards their parents. Second is programming language clustered together, build framework separately. So that is what SC is used for. SCW, that is a skill co-occurrence weighting. It adds 8.7%. Frequently co-occurring tags get more weight using log scaling. Third is dynamic context window. Adds 6.2%. Related skills get extended context window. And the fourth is graph-based regularization as 5.9%. while Word 2 gives Ruby, Java, and C++ for handle code. Here, Python is to Django, as Java is to what? So next page. Exactly, MySQL is a database. Is to database, as TensorFlow is to machine learning. That is 0.2. So this model transfer relationship correctly. We deploy a class cap with 5 endpoints, all divided under 1 minute seconds per CPU, and model checkpoint is just about 5. Conclusion and future work. To introduce 4 novel components achieving 23 to 31% improvement over baseline expert to and fast and tested on 20407 resumes with over 50,000 inventions. We have built a production ready application. Future work includes multi-language support, LLM integration, temporal modeling, personalization, and proficiency. Thank you.
Okay, thank you, Mr. Paresh Kumar Prajapati. Now we are moving to Ms. Kavita Gupta. Is she there? Yes.
Hello.
Yes, Ms. Kavita Gupta, please share your presentation with us.
Hello everyone, and I'm very delighted to be part of it. I'm Kavita, and I'm currently doing my PhD with Manav Rajna International Institute for Research and Study. Is my screen visible?
Yes, make it in a full screen. Okay.
So the topic of mine, and thank you for this opportunity. I'm really delighted to be part of this. 25 years in marketing research and consulting and dealing with various brands and products, and I'm really thankful to the university for allowing me to do this. So my topic is a comparative study of generative AI responses and their emotional impact on pet care decision making. So we have compared actually 5 platforms for the same questioning. And if I go through the introduction part, so everyone is using modern conversational AI like ChatGPT for one of the information. And I have a question for all of you that have you used it for checking anything related to healthcare? You can deliberate amongst yourself and tell me later that whether you have used it or not. But definitely healthcare is the domain which is very complex because here decisions are being taken not for yourself but for someone else who cannot decide for themselves. A lot of time people who are pet owners, when they decide for their pet's lives and critical decisions, they get into ambiguity and a lot of distress. And also, there is always a caregiver dilemma that kind of follows in this particular category. So, while doing the literature review, we arrived at 3 important, areas where we felt that this research would be making some contribution. So, existing models to evaluate interaction and to evaluate frameworks for AI, which shapes, how people are using AI and how they are responding to various questions, which is very functional and which lacks actually emotional output and emotional explanations. So the key research that was that existing frameworks they ignore ethical emotional reasoning. So the question like does AI sound empathetic? Because a lot of conversation is going on whether AI is as good as human, where AI replaces humans. Those conversations are actually part of this particular research. Specifically to pet care industry, because pet care has to be specific evaluation. So not many researchers have been found in the literature that should focus specifically on pet care, and it's a very, very emotional area. And then third is of course the layer which we have added to my academics journey also. I'm trying to explore meta emotions. Meta emotions are actually feelings about feelings. It's not the first level feeling, it's actually once you experience an emotion and then when you reassess that emotion internally in your mind, then how do you finally feel and how do those final feelings affect the way you take your future decisions and work towards different events and eventualities. So these are the 3 core gaps with which we started, and we felt that because it's an AI world, so
let's compare that how repetitive, how emotionally responsibly AIs are there and answering the question. So we took a qualitative prompting approach. We have created a questionnaire, and I'll come to that. So the key result objective that we were chasing was like, how can we compare various conversational AI platforms, specifically these five: ChatGPT, Gemini, Perplexity, Meta, and Copilot. So most of the studies were comparing only 1 or 2 or 3 maximum. We said that we will do the time to identify what are the convergent and divergent points in their meta-emotional engagement, and secondly, identify thematic patterns and when they are asked questions about caregiving, and especially in the context of pet care, based on the attributes that we have decided, how are they, what are the patterns or the themes which are emerging, and how we can evaluate the performance of those assessments. And eventually all this was done to develop a final framework so that there is a system to evaluate these AI using meta-emotion as one of the layers, and therefore the meta-care is the final outcome that is expected out of this research. So we use prompt control qualitative, wherein we created a battery of questionnaire having 17 questions across routine care, dietary decisions, health concerns, and ethically ambiguous situation, because we also wanted to check that whether it takes care of the ethical layer of judgment or not. The prompts were standardized so that we have asked exactly same questions and same prompt were given to each AI for comparison. And then for the data collection, all the AI or the conversational modules were used like a non-logged-in format. So it's like there was no background or a history of search, so that there was no bias, and an anonymous search was conducted to get the answers. And for the data analysis, of course, we used qualitative but three-layered analytical approach. So first layer was the construct validation, so responses were coded, and the presence and the manner of expression was coded, and then cross-platform themes were evaluated, and then of course the most important part, which was also going to be part of our evaluation framework, we have examined and observed how they responded to particular emotions and meta-emotional layers. This is a brief snapshot of how coding was done and how all the AIs and their responses were coded and analyzed. So there were interesting findings that there were some areas of convergence where almost all of them, did this kind of reflected answer in the same way. So most importantly, all 5 conversational AI systems demonstrated substantial construct convergence across ethical, emotional, and advisory dimensions. And it was very much observed in welfare prioritization, ethics, and responsibility training. Criteria guidance was also very consistently ranged on welfare first ethical reasoning rather than fetch prescriptions. And meta-emotions, particularly responsibility, guilt, and anxiety, those kind of final secondary feelings were present, and with variation in explicitness across systems, these variations were present. And differences were actually in the extent to which they were expressing or expliciting meta-emotions, or differences were actually in the way some AI tools were behaving versus others. And so, for example, ChatGPT and Gemini followed more of reflective and principle-based guidance. However, Perplexity, Copilot, and Meta AI, they followed more of procedural threshold-driven guidance. So, immediate advice versus more thoughtful advice and asking more questions was kind of differences which were observed. So more, yeah.
Sorry for interrupting you, Kavita. Do you have your presentation with you? We cannot see your presentations over here.
Oh, I'm sharing the presentation. Are you sharing this?
No.
Oh, let me just reshare.
Okay. And please move to the conclusion very fast. We are actually running short of time also. Okay?
Sure, ma'am.
Yes, we can see the presentation. Now please hurriedly move to the conclusion and the major findings of your research.
Yeah, so I think one major finding is that all the 5 AI platforms have a very different archetype. So if ChatGPT is a reflective counselor, then Gemini and Meta AI are more of anxiety regulator, and they don't become the counselor, but they guard themselves, and they always give the responsibility to the user to take the final call. And out of this, the key finding is actually this evaluative framework which had emerged out of entire exercise, having 3 distinct layers. So layer 1, which drives perceived usefulness, immediate trust, and decision support quality. And there are constructs to the layer which are defined. And this is actually advisory construct layer, and this is fundamental or foundational layer for the meta-emotional, meta-care framework. Second layer is ethical discursive engagement, which actually shapes user perception, moral responsibility, obligation, and accepted social norms in pet care giving, because of course other context was pet care, but however, having said this, this can be extended to other healthcare and monitoring or caregiving systems as well. So the most important part is the meta-emotional layer, which we have kind of evaluated, and if the basic question that does AI found empathetic. Now the need is to ask the critical question: how does AI shape users' emotional self-appraisal? Because it was found that AI gives answers, but it also makes user accountable by taking care of the pet-related guidance and advice. It also advises and advocates for supportive care. It does not allow user to shun away from their own responsibility and put everything on AI. So they are that responsible. And based on this, there are 4 practical and theoretical implications which we have kind of laid out, which also include that the system can be extended to other caregiving domains as well. And I think it's just that this whole exercise led us to believe that though we are getting more of AI and artificial, the empathy questions should move more to responsibility and meta-emotional acknowledgement and self-appraisal and self-regulation as well. Thank you.
Okay. Thank you so much, Kavita. Now we are moving to our next presenter, Professor Dr. Amrita Sahu. Yes, ma'am. We will be sharing your PPT as well. Yes, ma'am. Please start.
Good afternoon, everyone. Today's my topic is influence of artificial intelligence on financial decision making among women in Bhopal and American investigations. So, in this presentation, we have explored how artificial intelligence is influencing financial decision making among women in Bhopal. Specifically, the study examines how factors such as digital literacy, perceived usefulness, and this shapes the adoption of AI-driven financial tools and ultimately affects women's financial independence. So, artificial intelligence has significantly transformed financial services through tools such as robo-advisors, automated investment recommendations, and personalized budgeting platforms. While fintech adoption is rapidly growing in India, women still face several barriers to active participation in financial decision making. These barriers include limited financial literacy, technological gaps, and socio-cultural constraints. Moreover, most existing studies focus on large metropolitan areas, leaving a research gap in tier 2 cities like Bhopal. So research gap basically find here is limited empirical studies on AI and women financial behavior in tier 2 cities. So that's why the study area has prepared as a Bhopal. So the major objectives I have here. So to examine the role of digital literacy and financial literacy in AI adoption, analyze how perceived usefulness and risk influence financial decision making, to evaluate the impact of AI engagement on women's financial autonomy and to understand how AI contribute to economic empowerment of the women. So these are the objectives. The conceptual framework integrates the technology acceptance model with behavior, finance and empowerment theory. Digital and financial literacy influence the perceived ease of using AI tools, ease of use, enhanced perceived usefulness. Trust plays a critical psychological role while perceived risk negatively affects trust in these cognitive and behavioral factors influence financial decision behavior, which ultimately leads to financial autonomy. So, methodology we have chosen here, the sample size we have taken here, the studies based on the quantitative cross-sectional research design. Primary data were collected from 200 women aged above 18 years. Urban, semi-urban, rural areas of Mumbai using statistical scale questionnaire. The data were analyzed using
Sir, next slide.
And for the testing reliability, correlation, multiple regression model were used to examine relationship among the variables. So we come to the results. The results show several important findings here. So digital literacy significantly improves the perceived ease of using AI financial tools. Perceived usefulness plus together explain about 41% of the financial decision behavior. Perceived risk negatively affect trust, indicating the net privacy and security concerns reduce confidence in AI systems. Most importantly, financial decision behavior strongly predicts financial autonomy, demonstrating that AI tools can significantly enhance women's economic empowerment. So, what can be the implications here? So, these findings have important practical implications. Policymakers should promote digital financial literacy program targeted at women. Then, fintech companies should design user-friendly platform with transparent algorithms and strong data protection to build trust. By improving accessibility and trust in AI systems, these tools can contribute significantly to women's financial independence.
Okay, next.
In conclusion, we have the AI-driven financial tools have strong potential to empower women economically. However, the effectiveness of these technological depends on digital literacy, trust in AI systems, and transparent financial platforms.
Next slide.
When these factors align, AI can significantly improve women's financial decision-making
next slide,
and
sir.
autonomy. These are from my side. Thank you for your attention. Have a nice day.
Okay. Thank you so much, Professor Dr. Amrita Sahu. Now we are moving to our next presenter, Anisha. There were certain technical glitches, so she can be connected right now? Yes. Yes. Please, Anisha, give your presentation. We are again encountering the same problem that we have encountered earlier.
Is it okay, ma'am, now?
Yes.
I see.
But kindly share your presentation. Anisha, we are still getting some No, it is not visible. We are moving to our next one, that is Dr. Bhakti Parashar. We will get back to Anisha as soon as the technical glitches from her end is being done. Dr. Bhakti Parashar, if you are ready, then kindly please share your presentation. Yes. Yes, you are audible. Kindly share your presentation. She needs, yes, it is visible.
Okay, good afternoon for one and all. I am Dr. Ramesh, presenting my presentation on AI-driven education system. Is it visible now?
Yes, yes, yes.
Okay, AI-driven education system. And here in my study, I tried to find out that what are the opportunities and challenges we people in education system find while teaching to students. So this is an introduction of AI, how the AI when it came to our education system is helping us to transform from the traditional education to the flip-flap education and the online education. We can increase the interest of the student when we add some AI-powered assessment tools, when we add some creativeness in our teaching method, and definitely it is helping us to transform our traditional education system to the diversified and very interesting education system. So when we talk about the AI for assessment efficiency, it definitely improves education administration by automating the content, including some learning experience. We can add some of the live case studies by using the AI. So this study actually examines three things: AI-based personalized learning, how it is actually helping us, and then second, how AI support us to create content and evaluation, and then how this AI-driven administrative innovation can be used. So the main purpose of my study is to analyze the benefits and challenges of AI in building this more inclusive education system and how we are adaptable to this new education system by the inclusion of AI. So these are the literature review I have included, and the reference is also given us at the end of the PPT. Some of the literature I want to mention here, like definitely the role of AI integration for this instructional and organizational purpose is very important. We can adopt this platform for making our classroom teaching more effective in a large and diversified manner, so that the students have more interest and they will become more attentive. One more thing we can use, then we can use adaptive program system, we can use effective IPS and generative AI and chatbots are very helpful us to create some supported content, like we can make videos, we can make some of the interesting case studies by our own. And then there are some concerns about the algorithmic violence and automated systems, as machines can also do errors. And the main important challenges which I have started in the literature review is that issues of the data privacy and the ethical data governance is always a critical, like cybercrime and all that. The data privacy is always the leading challenge for all of us when we are using AI. And the challenges like data scrutiny, transparency, whether the faculties are ready or not, we are trained to use this AI or not, because students are also nowadays very smart and they are constant ahead to us in terms of technology. So they can say, okay, this content has been taken by the faculty from this platform. So ethical concerns are very important, like academic integrity, authorship, and responsible AI users is very important. So for this, the methodology I have used, I have taken the qualitative data, where the focus area I have already mentioned, the personalized learning, content-created assessments, and AI-driven innovations. Where I have taken the 90 studies, I have started the 90 studies which published from 2018 to 2025. My method is totally based on the thematic analysis, where the things like personal global engagement, automated assessment, efficiency, and I have used the academic sources, highly scientific studies, and the limitation of my study is totally based on the secondary data. So the rapid AI advancement may affect long-term relevance. So this is my also the data where I have mentioned the AI powered personalized learning. So out of the 90 studies, 42.2% people are basically from this AI learning are not ready to accept it or adopt it because there is always a gap that this is a new technology, maybe we are not able to learn it, we are not ready to accept it, and for every AI tool we need to pay something. So that is accessibility and inclusion is a major part. Second thing is cross-application AI application domain and ethical concerns also I have started, where this chi-squared test I have done, where the X value is 6.1 and P value is 0.045. So ethical issue appears more frequent in personal learning studies, which actually is very important to use the learner's data. So the empirical report, more practical benefits has taken here, where the X value is given 0.027. There, the result is that there is no relationship between AI application domain and ethical concern studies and alternative hypothesis. There is a relation. But then our interpretation is this probability P value is 0.045, this is less than 0.05. So where the null hypothesis is rejected and the alternative hypothesis is accepted, that there is a relationship between the AI application domain and ethical concern study. The next table is telling us about the relationship between study time and report benefits. So here also I have put this chi-square, where the chi-square value is x square is equal to 4.87 and the p value is 0.27. So the analysis of this is that there is no
पिल्लांचे ठीक है वैलिडिटी कितने बजे
now the interpretation is 0.027, which is again here we reject the null and accept the alternative then this is again another table I have analyzed, where the personalized learning themes is 3.8% and mean theme for study is 3.8, create content creation and assessment is 3.2 and administrative evaluation is 3.6. So this is my key findings of my whole study, that definitely AI for personalized learning is more reached area, that is 2.2% of the study, which highlights that strong focus should be on student-centered and adaptive learning. We cannot ignore this AI nowadays. Right? So AI generated material is very much important, but we need to add our own original work also in it, so that there won't be a chances of ethical concern, there won't be a chances of, you can say, the learners finding the fault of the faculty and finding that this is the, this is the platform from which the faculty has generated new old content and then the faculty is teaching. So this AI research mainly focuses on pedagogical improvement rather than the distributional management. So this is my conclusion, that ethical issues are always there, data privacy, algorithm bias, transparency and accountability, which we need to focus on. We cannot ignore AI research in education, but then if we are applying it with a proper strategy, our teaching learning methods definitely will be improvised and it will reflect our personalized learning, transform into teaching. And then accessibility and inclusion receives that comparatively less attention, which needs a lot of attention. Like we are having democratized education system. So in our education system, we all have a right to use the latest version of AI. And then overall, AI has transformative potential in education, but future research studies focus on equity, governance, and administrative innovation, which is very much helpful for us and for the responsible sustainable AI adoption. So these are some of the references I have mentioned, or from these references I have taken in my literature review. Thank you so much.
Okay. Thank you, Dr. Bhakti Parashar. Now we are moving to our next presenter, Kanchan Bharti. She is... Okay. Please, Kanchan Bharti, start your presentation. And kindly confine it to 5 minutes. We are actually running short of time, okay?
Sure, ma'am. My screen is visible, ma'am?
Yes. There's some echo is coming from your... Yes.
Good afternoon, everyone. I am Kanchan Bharti from the Educational Institute, Agra. I am here to present my
Kanchan, please shorten up your... Kanchan, kindly shorten up your presentation. Kanchan, can you hear me? Sir, kindly unmute. Kanchan, can you hear me? Yes, please shorten up your presentation. Okay? Yes. Okay, thank you so much, Kanchan Bharti. Now we are moving towards Mr. Rohit Tiwari.
Good afternoon, am I audible?
Yes, please share your presentation with us. No, not yet. Yes, yes. Rohit, we cannot see your presentation. If you are having some technical glitches, you can read out your presentation as well.
I'm just trying once again, ma'am. If not possible, then I'll read out my presentation.
Okay.
Is it visible now?
No. Yes, now it is okay.
Good afternoon to the esteemed chair members. I am Lieutenant Rohit Tiwari. I will be presenting the paper on leveraging AI and data analytics on enhancing the battlefield efficiency. Primarily, the aim of this paper was to create a research to explore how AI-driven analytics and predictive maintenance and intelligent surveillance systems can improve the operational efficiency in a modern military environment. It also includes the discussions like AI-driven Facial prediction is also applicable and can be incorporated for prior knowledge about the system, which makes our prediction furthermore capable. The concept enables updated probability as new sensor data arrives, improves reliability over static models. Even the machine learning optimization that includes the cross entropy loss. The cross entropy loss enables us to have a commonly used for binary classification problems, and it makes the system more flexible and accurate predictions compared to traditional statistical models. The experimental results, as I just wrote out, we worked out for experimental result of 10,000 simulated equipment and their performance, and the model assessed in 3 different categories, that is logistic regression, random forest, and deep neural network. If we compare the accuracy, the deep neural network is the overall winner in terms of the performance per se. Similarly, the other factors can also be seen on the viewpoint. The AI in ISA system, as we have discussed earlier also, it includes all the sensor information getting fused, then coming on to the decision cycle, which we have discussed earlier. In the AI in ISA system, as we see, the operational efficiency is very important. The graph given in the left side, you can see the data, sensor data makes it 50% of the operational efficiency coming up, and with the complete cycle being followed, as we discussed in the last slide, we can up to receive almost median 90%, more than 90% operational efficiency. If we compare this in the right graph, we can see if the traditional data is concerned or the traditional ISR is processed, the processing latency index is quite high. And as and when we apply the AI enhanced ISR, the processing latency goes down. The case study I have also worked out a case study with the ongoing wars that include the Russia-Ukraine conflict. The conflict has seen huge amount of AI-driven data being utilized in ISR and drones being utilized in it. Use of commercial satellite imagery in POSNET, and all these informations have played a vital role in the real-time battlefield intelligence. The global militaries have adopted AI in a large way, especially NATO countries where they have already migrated onto autonomous drones, ISR, analytics, and cyber defense. Similarly, China is also waved this way forward. India is in a stage of implementing these things, but we have made good progress in logistic analytics and predictive maintenance. Globally, if you see, the complete world is shifting towards the AI domain, and we may look forward that these models are being accepted in very short frame. My recommendations would be that we develop as a centralized military AI data platform, wherein we are able to train the personnel on AI data annotation, integrate all the AI in defense simulations, and collaborate with academia and industry to achieve better results. In conclusion, I would say that AI and data analytics gives us better predictive maintenance, better ISI intelligence, better decision supporting system, and a higher battlefield efficiency and situational awareness. For the paper, I have referred to all these papers and studied through these particular references. Now, I am finished, ma'am. Any queries from you?
Okay, thank you so much, Mr. Rohit Tiwari. Thank you for joining us. Now we are moving to our next presenter, Professor Dr. Saroj.
Good afternoon. Hello.
Yes, please start your presentation.
Sure, ma'am. I'm trying to upload.
नहीं. No. Yes.
Ma'am, is it visible?
Yes.
Okay. So myself, Dr. Ramesh, Professor, Department of Fine Arts, Practical University, and my co-author, Dr. Professor in Economic School, Global University, Bhopal, and from my university, Rohit Kumar Roy, co-authors. And the introduction and background, the art therapy supports emotional healing, visual language, self-expressed inner feelings, AI enhances digital creativity and analysis. Objectives, study therapy role of art therapy, examine AI integration, understand symbolic expression in artwork. Research methodology is scholar that qualitative theoretical study,
यशवंत वही है नहीं विजय अमरनाथ के बाद करवा हाँ मेरे पास भी आया उसका बोल दीजिए
This is the one data taken from the India where they are art therapy, how they are treating the ill-minded people through mental disability to the AI supported art therapy treatment. The resultant discussion improved the cognitive engagement, reduction in depressive symptoms, AI identified symbolic emotional pattern. And the conclusion is art therapy supports healing and self-expression, and AI improves analysis and accessibility, and human therapy to clients' relationship remains central. Thank you, ma'am.
Okay, thank you so much, sir. Now we are moving to Mr. Vijay Amarnath.
Yes, ma'am.
Okay, so please share your presentation.
Yeah, sure. Can you please see my screen?
Yes, sir.
Okay. I'm Vijay Amarnath, and thanks for the opportunity to discuss the university. My topic is integrating application user in art and design and animation, and thanks for my very good answer. Is a transforming field education. Now, production line, a lot of people are using AI tools for creating visual design and animation productions. They're creating character design and animations for the university, and they're using for content creation also. When it comes to education, there is some practice. That's what I focus on mostly. So, how is the AI tool between you? That's what I'm making. And my research problem is that fundamentals and
might be very important for the service framework. And based on that, I made some curriculum. Phase 1 is foundation and phase 2 is integration, phase 2 is discussion. The phase 1 is we just going to teach only the foundations. There's no way to go into the and phase 2 we just incorporate AI assisted work so they can able to know the AI. And phase 3 they completely specialize on the AI tool. Based on that, I just create some videos, some sample videos. This company. This company. This was completely done in AI, from scratch to start, concept based into and this is what I'm doing in visualizations. These are my visions. Thank you so much.
Okay. Thank you so much, sir. Now we are getting back to Mr. Yashwant Anand. Okay. Mr. Yashwant, yes, you are very much audible. Can you?
To the respected jury, our project is AI-based question paper generation system based on Bloom's taxonomy. The problem with the traditional education system is that preparing question papers is a manually time-consuming task, and it leads to such issues like question preparation, uneven difficulty distribution, and lack of cognitive balance. And most existing systems only grade basic questions and do not ensure proper distribution across Bloom's taxonomy levels, like remember and understand, apply and analyze and evaluate and grade. So we created a system to solve this very problem. So what we propose is AI-based question paper generation system, which where the faculty just uploads a high quality material of the particular unit, and we use a RAG model in there, and we just extract the text content, chunk it and split it and store the embeddings in the vector database, and we retrieve it with an open source large language model so that the data levels leaks are reduced. And so this is how the questions are generated. Like we also have added fetch requests so the web crawler can search the internet and retrieve the document. We also added difficulty levels for PhD scholars, research scholars, and UG and PG students. So the results are developed to successfully generate balanced questions and structured question papers, and it significantly reduces the faculty's workload and time required for exam preparation. And the questions are really relevant, diverse, and cognitively aligned with Bloom's taxonomy. And in conclusion, the system provides an efficient and intelligent solution for automated question generation system, and by making AI and Bloom's taxonomy, the system ensures structured assessment that values both basic knowledge and higher order. Thank you.
Okay, thank you so much. Is Aarti Singh is still there with us? No? Okay, so we have just concluded our today's session. Thank you so much all the presenters for joining us, and thank you for being associated for last 2 days into integrating sessions of artificial intelligence. We hope that the insightful insights, the actionable remarks that is being made by all the experts, the presenters, that is going to give a new dimension to the works that we are going to do in artificial intelligence from now onwards. Now I thank you all my team members members, the students, the delegates, the stakeholders, the academicians from different university for joining us. Thank you so much for being with us, listening to us patiently, cooperating in every kind of technical glitches that we have seen. So we are here once again and we will meet you soon. Thank you so much and we will see you soon later then. Till that, goodbye. Thank you.